Okay, Jane, here are some ideas for solving this problem. I wanted to first draw a picture of this cone to show you the thinking that was originally incorrect by me. I'm so used to doing these cone problems where you draw this radius and then the radius of a typical slice of water down here. And indeed, because this is a straight line here, the edge of the cone, or a cross section, these are similar triangles. But if you try the same thing here, this edge is not a straight line, so you cannot create similar triangles. So we have to find a formula for this radius right here, based on a coordinate system where I called this y equals 0 and this height right here y equals 5. So that's why I have the integral from 0 to 5, because the hemisphere is full. The question is, what is the volume of a typical slice of water? And to do that, we have to find R. So the area of that small slice is pi times R squared, obviously. And then the volume will be pi R squared times delta y. And the force involved will be multiplying that by 62.5. Okay, so how do we solve for R? That's the question. And here's the thinking. If I draw this radius of the hemisphere to right here, that will also be 5, because from the center of the hemisphere to any point on its surface is always 5. And this distance right here, well, we're calling the coordinate of that point y, because we're going from 0 towards 5. So, for example, this could be a 3. But in terms of y, this distance right here is 5 minus y, because this is this distance right here, and I'll go to a different color. That distance right there is y. So now we do have a little right triangle right here where r squared plus 5 minus y, the quantity squared, equals 5 squared. So let me write that down over here. R squared plus 5 minus y, the quantity squared, equals 25. And so r squared equals 25. Subtract this term, and while I'm at it, I'm going to expand that trinomial to 25 minus 10y plus y squared. And then if I remove the parentheses, I get 25 minus 25 plus 10y minus y squared. And of course the 25's cancel, and there's r squared. I could say r equals the square root of 10y minus y squared, but in the end I want r squared to go in the formula. So that's where this comes from, right here. That's the radius squared, and I've got the pi out front, and I've got the 62.5 from the force function. So it's 62.5 times pi times r squared, 10y minus y squared. and then work is equal to the derivative, the integral from 0 to 5 of this right here, the force function, times the distance that it moves, and that's the 5 minus y. Okay, so I'm going to leave the calculation of this definite integral to you. You can see what I got on Desmos, the picture that I sent was 30,000 something, okay, per foot-pounds, rounded to the nearest 10 foot-pounds. Okay, there you go. Hope you understood that.